This is my second ShowMe. It's about solutions of linear equations in two variables. This sort of topic is very, very important and very common in pre-algebra and Algebra 1 classes, and in American education anyway. Those are the gateway classes to college entrance opportunities. So it's very, very important that you understand how to use this. It's also a very important idea used to represent information in the media and in science. First, let's talk about what a linear equation in two variables really is. It's what we call an open sentence, with two variables both in the first power. Now, since it says equation, our open sentence has to have a particular verb, and that verb would be an equal sign. So, no matter what, equal will appear here because we're talking about a linear equation. An open sentence means that there are variables in the sentence, things that we do not know, without perhaps doing some extra work or going out and obtaining extra information. In this case, there are going to be two variables. The default variables are x and y, but they could be any variables that you choose. So a typical linear equation, two variables, might look something like this. 3x equals 4y minus 2. That's a linear equation in two variables. Now this bit about the first power, notice that the x and the y don't have exponents on them. In the math club, whenever we see a variable with no exponent visible, we actually all know, because we've all agreed on it, that the exponent for each of the variables is 1. If the exponent were to be anything other than 1, it would be written. So when you don't see an exponent, it's 1. In linear equations, those exponents have to be 1. If those exponents are something else, then we are not dealing with a linear equation. When we talk about solutions to linear equations, we're talking about numbers that make an open sentence true. In other words, we want to know what numbers might we put into this equation, 3x equals 4y minus 7, to make it true. If we find a pairing of numbers that makes it true, then that ordered pair would be a solution. Consider then if x were 7 and y were also 7. Then on the left side of the equal sign, we'd have 3 times 7, which is 21. On the right-hand side, we'd have 28 minus 7, which is also 21. That makes it true. That means that for this particular equation, one of its solutions is the point, the ordered pair 7, 7. That's where x is 7 and y is 7. If we were to make a graph of all the solutions of this equation, 7, 7 would be a point that's included in the graph. If a point didn't make this true, it wouldn't be on this graph. It would be elsewhere in the graph. It would not fit with the set. One of the beautiful things about linear equations like this one is that when you graph all the solutions, they make a straight line. That is extremely useful for making predictions, seeing patterns, and understanding the relationships between independent and dependent variables. So let's try one of these out and see how it goes. I've got a linear equation up here, y equals 3x plus 4. Our job is to determine some solutions and then make a picture of all the solutions. We know they make a straight line, so if we have 2 or 3 and they're all lined up, then drawing the line through them all will take care of the business. So we need a table which will help us calculate these values. I like to make a table like this one, where x is on the left, 3x plus 4 has its own column where we do our thinking and calculating, and then the result of our calculation appears on the right for y. In other words, x truly is an input and y truly is an output. I like to pick 3 different kinds of numbers to put in. I always use integers first of all, it's just easier. But I always use a negative, I always use 0, and then I always use a positive number. So in this case, we might use negative 2, 0, and 3. That will give us 3 points. If they all line up, then we know we've done it correctly, and we can graph the line. So let's put negative 2 in for x. We'd have 3 times negative 2 plus 4. We have to do multiplication before addition, so we take 3 times negative 2, which is negative 6, add 4 gives us negative 2. So one solution to our line is negative 2, negative 2. but there are infinitely many solutions. We need a couple more to draw a nice accurate line that represents all of them. Let's put 0 in for x now. So we have 3 times 0 plus 4. Again, multiplication first. 3 times 0 is 0, and 0 plus 4 is 4. Finally, put 3 in. So we have 3 times 3, which is 9, plus 4, which is 13. Now it's time to make a picture of all this and see what it looks like on a graph. So here's all the information that we generated on our previous screen. The equation of our line is y equals 3x plus 4, and we have 3 points that we generated using our little table approach. Now it's time to graph the points. The first point is negative 2, negative 2. Starting at the origin, go to the left 2, and then down 2, and this is negative 2, negative 2. Next, do 0, 4. So 0, then 1, 2, 3, 4. This is 0, 4. Finally, 3, 13. So to the right 3 and up 13. And that's a representation of that point. Looking at them, they do seem to line up nice and straight. Draw a line through all 3 points. Lines, of course, go on forever. So put arrows at the end. What we've got here is a picture of the graph of y equals 3x plus 4. You see, there are infinitely many solutions to this line. Infinitely many points. We don't have time to make a list. They say that a picture can be worth 1,000 words. This picture is worth infinitely many points. It also gives us a visual image of the relationship. Obviously, there's a standard change relationship here. If x changes so much, y changes so much, and those numbers don't vary. That's going to be a very important idea related to linear equations. You're going to spend a lot of time exploring it, and eventually that notion forms the foundation for calculus. So you're really getting a lot of important foundational information from studying linear equations in 2 variables. Let's do one more just to make sure that we've got it. In this case, I'm going to let the number that's being multiplied by x be a fraction, which you'll discover it often is. We'll build the same table that we built before, a column for x, a column for calculations, and a column for y for our results. Now, a situation like this requires a little bit of craftiness. You see, I don't really want to work with numbers that aren't integers, but when you multiply by a fraction, sometimes you get a fraction out. I really don't want to mess with that right now. Graphing is so much easier when we're dealing with only integers. So what I'm going to do is I'm going to choose numbers that are only multiples of my denominator. In this case, the denominator is 2, so I will only choose multiples of 2 to put in that column for x. If that number on the bottom were 3, I would only choose multiples of 3. So, multiples of 2 it is. Let's use negative 2, 0, we always want to use 0, and 4. Notice we didn't use 3 because 3 is not a multiple of 2. This is going to help us stay with the integers, makes our graphing easier. It doesn't really change anything. It doesn't matter which 3 points we graph. We need 3 to make sure that we've done it correctly. So let's put negative 2 in. We're going to take negative 1/2 times negative 2, and then add 3. Well, negative 1/2 times negative 2, that's a negative times a negative, which is a positive, and half of 2 is 1. So we have positive 1 plus 3, which is 4. Now we do the same thing for 0. Negative 1/2 times 0 plus 3. Well, anything times 0 is 0, and 0 plus 3 is 3. Finally, we'll put 4 in. Negative 1/2 times 4 plus 3. Well, negative 1/2 times 4 is negative 2, and negative 2 plus 3 is positive 1. So now we have our 3 points ready to switch screens and graph this and take a good look at it. So let's graph our 3 points and get a look at this. We've got negative 2, 4, so starting at the origin, go left 2 and up 4, and that point belongs right here. Negative 2, 4. Now 0, 3. Go to the right 0 and up 3, and there's the point 0, 3. Finally, 4, 1, so go to the right 4 and up 1, there's your third point. Again, they do line up nice and neat. If I can draw a good line, that is. 4, 1 is right here. That's better. Okay, there's your line. That's the equation of the line, and those are the points that make it true, that make the sentence true. Again, notice the direction of the line does not change. That's a very important feature of lines. The direction never changes in a linear equation. So when you graph it, you're always going to get that consistent direction. It's one of the most important things about the line. So let's sum up the lesson. First, we learned about linear equations in two variables, and that's going to be a particular focus for your courses in pre-algebra and algebra 1. So don't let that bug you too much that we're not going beyond two variables. Things only get more complicated, but also more useful after that. There'll be a time for that, but first you've got to learn how to crawl before you walk and how to walk before you run. Okay, linear equations feature variables that are all to the first power. If the variable appears to be to any other power, you're not dealing with a linear equation and its graph won't be a line. Remember, one of the most important things about linear equations is that the graph is a straight line. That's why the word linear is applied here. The other term we learned about was solution, and a solution is simply a set of substitutions that makes the equation true. Because of this equation that we're looking at here has two variables, we need two numbers. So we create an ordered pair, one for the x value and one for the y value. And each of those that we select has to make it true. Then if we take those and graph them on a graph, they make a straight line, an infinite straight line. And that picture is valuable because, once again, such a line has infinitely many solutions when you look at the real numbers. There's no way to list them all. There's no way to make a table of them all. You'll die before you're done. The best way then to represent them in a way that represents all of them, or at least has the chance to, is to make a picture. So again, a picture is worth 1,000 words, but a graph can be worth infinitely many points. There's my second Show Me. Hope you liked it.